All right, welcome back, everybody. When we're going map 335, and that this section is for. What were we studying on Thursday? We were looking at exponents and polynomials. So let's like delve into that some more. And let's just give you guys some problems and we'll go over them together a little bit. So the idea on all these tasks is to simplify. We will have 2x squared y cubed to the second power over. Now let's make it to the fifth power. Oh yeah, let's kick it up a notch. And let's put this over 4x y to the fifth, the eighth squared, like that. Simplify that. No, I'll come up with another one. I just get that one. Okay. Wait. Oh, hi, Sensi. How are you doing? Hey. What is going on? Hey, Christopher, can you hear me?
Yeah, I can hear you. Can you hear me?
Yep. All right, so give you another minute to simplify this. What should I do first? Need more time since you. That's right. Or at least on the first one.
I got the first.
Oh, you're on the first one?
Oh, no, I got one.
What should I do first? Anybody? Yes, Senzi, since you foolishly spoke out loud, you come in if you want.
The first section,
Okay, don't want to do that first,
Okay.
because the remember, we're going to follow order of operations.
Oh, okay.
And we have to do PEMDAS. And there's really nothing to do inside these parentheses, so the P's out. So the first thing we have to address is exponents.
Yeah, so what do you do the two things?
Yeah, we're gonna do the 2 to the 5th power.
Yeah.
I'm glad that you said that though, because it's a common mistake and it's worth having it out loud. And a lot of people do it, don't. So what we're gonna do is we're gonna take this exponent, we're gonna distribute it every exponent, including the exponents we don't see. If there's a number there and it doesn't have an exponent, it's got an exponent of 1. The same goes with this x. So I'm going to distribute this, and we're going to do it by multiplication. So I'm going to have 1 times 5, and then x squared will be 2 times 5, and then y cubed will be 3 times 5. On the bottom, we're only distributing square. I've got 4 and 1 times 2. X is 1 times 2. And y is to the 8th power times 2. So I have 2 to the 5th power, x to the 10th power, y to the 15th power. Let me block that off right there. And on the bottom, I have 4 squared, x squared, y to the 16th power. Now, I didn't write out what 4 squared was and 2 to the 5th power was, because we want to simplify, which means canceling out anything that's in common on top and bottom. And even though they don't look like there's anything in common, 4 squared is technically 2 squared squared. Because 2 squared equals 4. So this is like 2 to the 4th power down here. We're going to replace that with 2 to the 4th power. And it's just coincidence that the numbers swap places. Now, I think the easiest way to go from here is actually, we can cancel out things that show on top and bottom. But if there's something on top and bottom, what we can do is when it's division with exponents, we can treat it as subtraction for the exponents. So 2 to the 5th over 2 to the 4th, I can write as 2 to the 5 minus 4. And I can do the same thing with the x. 10 over 2 is 10 minus 2. And y to the 15th over y to the 16th is 15 minus 16. This will give me 2x to the 8, y to the negative 1. And things that have negative exponents can move to the other side of the fraction and make the exponent positive. Another way of doing that, if you're not comfortable doing that, I've got 2 to the 5th power and 2 to the 4th power. I can write out 2 to the 5th power like that. And I can write out the 2 to the 4th power like that. Just the number of exponents is how many times the 2's show up. And I can cancel out 2's until I'm out. But I got to cancel them out in pairs. And anything I cancel leaves a 1. So I'm left with a bunch of 1's multiplied together times 2, divided by a bunch of 1's multiplied together. So 2 divided by 1 is 2. That's where I get the 2. I can do the same thing with the, no, I don't want to do this with the x, but I can. X to the 10th, 4, 5, 6, 7, 8, 9, 10, over 2x's. Cancel them out in pairs, one down here and one down here. And I'm left with 8 of them up top, which gives me my x to the 8th. I think the subtraction is easier. You just have to remember to do it. And you need to remember that negative exponents move to the other side of the fraction. Any questions on that one? Yeah.
We can have like that what we're getting, right?
Say that again.
Like the group.
What? I'm not working in it right now. I'm just making up problems.
Okay.
This is just practice on the skills that we're doing. No, we're not doing homework. If we get to a point where homework is the better choice, the problem with homework is not everybody has a laptop, so it's kind of hard to choose homework. We're not on a laptop room. But I can reinforce the skills that you've learned in the previous section, and there are skills you're going to need. So it's helpful. Did everybody, Sensi was still running, did anybody else need more time on the second one? Let's give you guys some more time.
I have a question.
Yeah.
Did you ever talk to the library about the books?
Someone was over there. I submitted the thing for it on Monday. This class was the only one reason, for some reason, it had not been submitted. Every other book had their codes in, and I did it on Monday morning. Should be in there now.
Okay, I'll check.
Uh,
The access code.
right, yeah, I know. Do you know when you're gonna check? Okay. Ooh, 11. I'll be in a class at that time. If you're there before 11, like 10:50, are you in class till 11?
No, I'm going to class.
Okay. I'll give you my cell phone number after, like, when it's in the Canvas stuff too. If you're there and they give you a hassle, text me. And I'll step out of the class that I'm in and give them a call.
Looks like.
Yeah.
Okay.
This pencil still on, I'm moving that one out, who's still working on it? Anyone still working on it? Okay. So again, we want to go through the order of operations. So like, there's nothing going on inside the parentheses. There's stuff in there, but there's no operations to do. So next is addressing exponents. And these ones are easy. Anywhere I don't have an exponent, I can put in 1. And remember, when you're distributing, it goes to every exponent on the inside, even to the ones in the denominator. So this first one will be 2 to the 1 times 2 over 3 to the 1 times 2.
Can you explain that again?
Yeah, when you're distributing exponents on the outside of the parentheses to the inside, it multiplies to every exponent in the inside, even the ones that are in the bottom.
Oh,
So I had 2/3, they were both to the first power, so 1 times 2 on both of them. And then I will do the same thing on these. A to the 3 times 3, B to the 2 times 3, C to the 1 times 3. Here I got 9 to the 1 times 2, divided by 4 to the 1 times 2, A to the 1 times 2, B to the 2 times 2, C to the 3 times 2, D to the 4 times 2. Now, writing it out like that, showing like leaving the multiplication there but undone, is not a necessary step. I'm doing it to make clear what I'm doing here. However, if you do it on like on a test or something, and you make a mistake, I know exactly where you made the mistake, and I can tell right away whether it's a minor one or a big one. And so if it's like something minor, you just said 2 times 3 is 7, something silly like that, I understand that you didn't fuck up the harder shit, like dealing with exponents, you just fucked up basic multiplication, which happens even to me. So it might be worth writing it out like this on a test. It's up to you. The more I see, the more work I see, the easier it is to make a single step worth less. Rather than like if it's big leaps. I don't know, and I don't know what you did wrong. I have no way of doing it. All right, so now I'm going to do all that multiplication. I've got 1 times 2 is 2, so I've got 2 squared. 2 squared. I'm going to write this over here. That's 2 squared over 3 squared. And I'm going to fill it in as 4 over 9. And then I've got a to the 9th power, b to the 6th power, c to the 3rd power. I see I've got 4 9ths right here. I'm going to leave this 9 over 4 as it is, showing 9 squared, rather than multiplying it out, because I can cancel some shit out. And I'm just doing the multiplication here. All right, so I need to address two things. I want to maybe address the constants or the things that don't have variables separately from the ones that do. So if I've got 4/9 times 9 squared over 4 squared. As long as it's all multiplication, I can cancel out things that appear on top and bottom. And like this is a 1. I'll put the 1 in real quick. And I could do this subtraction thing again. Or I could just cancel them out as I see them. Like if I do the 9 squared over 9 to the first power, doing the subtraction thing I did up above, I should end up with 9 to the first power, which is just 9. The other way is going, okay, I have 1 9 here and I've got 2 9s here. I can cross that 9 out with one of those 9s. So I'm just showing alternate ways of doing it, and I can do it with 4s. I know this is 4 times 4. So that 4, well, one of those 4s will cancel out with this one, and it just drops this exponent down by 1. And I'm left with 9 over 4. Now I go on to my variables.
Okay, so,
Yeah,
I don't understand why you pop up the exponent.
so when fractions, instead of writing 9 squared, I can write 9 times 9. And on the bottom, I could write, instead of 4 squared, I can write 4 times 4. So they're multiplied together. I can cross off 1 at a time on each. And I'll be left with 9 over 4. The other way of doing that is going, not writing this part, but going, I know 9 squared means there's 2 9s. And if I'm going to cancel out 1 9 down here, I need to cancel out one of the 9s down here or up here, which means I'm only going to have 1 left. So it's reasoning out this step without writing it down. If that's not something you're comfortable with doing, don't do it. I do not try to force that. You get practice with working with the stuff over time and you get better at it. Right? So when we had things like that, we multiplied it. When we have things like this, they're added together. Because I don't have a power to a power. So that's what I need to do with my variables here. I got my 9/4 still. And I've got a to the 9th power times a squared. So I'm going to do 9 plus 2. And I'll do that the same thing with all of them. I've got b to the 6th power and b to the 4th power, and I can add those exponents together. And I don't have any d on the left, which means I can just use the d on the right as it is. What?
This is gonna be on the test.
Yeah, polynomials will be on the test. I wouldn't, for me, I go faster than this. If you do that, you can go from here to here and go 3 times 3 is 9. 1 times 2 is 2. 9 plus 2 is 11. You can, if you're comfortable doing it. Otherwise, like if you're actually doing it and not explaining it to someone, it goes a lot faster. Keep that in mind too. Oh, wow, look at that. I did not plan that. 11, 10, 9, 8, that was unplanned. Awesome. And that would be my final answer. That is the simplified form. You can do the 9/4 out front like this, or you can put the 9 on top with the variables. And the 4 on the bottom. This left, they're the same thing, but the one on the left looks a little less like nicer. Any questions? You want to need this up longer? All right. Do one more thing on that, and then we'll do some multiplying stuff out. Simplify this. Excellent. That's right. There's actually only one thing to do here. Things with negative exponents can move to the other side of the fraction. So what should I get here? Yeah, 3y squared over x. The reason why I bring this up is because this is correct. Yes. Good job, Sensei. If you went from this to y squared over 3x, that's a no. The 3 doesn't have the negative 1 on it. This is a common mistake. So try to avoid it. And I figure if I bring it up in class, you're less likely to make that mistake. All right, let's do some multiplying of some polynomial terms. Let's start with 3x minus 1 times 2x plus 5. Let's multiply that out. So your goal here is to simplify without parentheses. Is ready? So commented on a crypto thing in Telegram, and I was helping somebody out, and immediately a scammer that was a scammer trying to call me. Oh, do you need help? I can help you. And I'm like, motherfucker. I'm like, I deal with this crypto thing all the time, that they know me by name. The people at the crypto company know me by first name. They would not contact me like this. Okay. So remember, what we do is we take everything in one parentheses and distribute it or multiply it to everything in the next. So I can do 3x times 2x and 3x times 5. Now, specifically write out what I'm doing. That does that part. And then this is, I would not write this down when you're doing it, but this is more for lecture purposes. And then I'm doing -1 times 2x, and then -1 times +5. That's what I'm actually doing. Doing the stuff we were just doing with the polynomials, or these things up here, we multiply the 3 and 2 together, and we get 6. X times x is x squared. And then I'll do that with the 3x times the 5. We multiply the 3 and the 5 because those are numbers, and we still have an x there. And I could do the same thing with these. -1 times 2x. -1 times 2 is -2, and then I have x. And I'm going to stack them underneath each other. Alternatively, we can write them side by side. And then -1 times +5 is -5. And I'll make a new column for that. And over here on the right, I'll just show it side by side. If you stack them up like this, where the variables with the exponents are the same, it's as simple as adding up and down. Or subtracting up and down. If you go side by side, this isn't too bad because you have, if you go in the same order, you generally have these two together automatically, if you've done it the right way. Or you've got to look for anything that has the same thing and still put them together. 15x minus 2x is plus 13x. This method saves space. Paper. This method is much easier for bigger parentheses. Like if I have more shit in parentheses. So let me give you guys another one. Remember, you can do multiplication in any order, so you don't have to go left to right. Yeah. Gee, champion. Feeling good about yourself?
No, we're talking about the settings, that's.
Yeah, I is it the one you were wearing last week? There was some that, you had one with flowers on it before too.
That clouds.
Oh, it was clouds, you're right. I remember it was something. So I got grandma sweaters. I'm messing with you. Yep. Grandmas always have stylish sweaters.
Oh, the time.
I don't know, the whole ugly sweater thing. Very rarely have I really seen a really ugly sweater. I've seen obnoxious sweaters.
Yeah.
But ugly, no, not a lot of ugly ones. Christmas sweaters can get very obnoxious though.
Different colorful ones.
Yeah. Yeah, or flashing colors, you're like, that, those are the ugly sweater ones. Right? Everyone done? All right, did anyone start with 4x plus 10 times x minus 1? All right, did anyone start with these two? This way is the easier way, so I'm gonna do the harder way, just so you can see it, and if you get the same answer the easier way, you're good to go. The reason why it's more work this way is because this is the coefficients are bigger. That's flat out the only reason. It's the only reason is why it's more, there's more chances for a mistake. So I'm gonna leave the x plus 3 right here, sitting outside. And I'm gonna do the 4x times the x minus 1 is 4x squared. And 4x times -1 is -4x. And since I didn't give myself a lot of room on this page, I'm not gonna stack them, even though I probably should have. Then I'm gonna do plus 10 times x is plus 10x. And plus 10 times -1 is minus 10. So I've got, if I clean up that middle part, and I want to before I start multiplying, I got 4x squared minus, or -4x plus 10x is 6x minus 10. And now we'll do this distributing. X plus 3, x times 4x squared. X times all of these is just a single x and there's nothing in front. All it's going to do is elevate all of these exponents by 1. X times this will make 4x cubed. X times this will make 6x squared. And x times this will make -10x. And now doing the 3 is only hitting the coefficients. 3 times 4x squared is 12x squared. 3 times 6x is 18x. And 3 times -10 is -30. Another way of writing this before you get to this step is doing x times 4x squared plus 6x minus 10. plus 3 times 4x squared plus 6x minus 10. And I'm writing that for a very particular reason, because when we go the other direction, and we will go the other direction, it's called factoring. It's helpful to recognize that's what we're doing. When we factor, we're undoing this to get back to this. And I will go over that when we're factoring, point that out, but we're going to now. So let's see, since I word them all next to each other, I got to go through and look for my cubes first. That's the highest exponent. I got a 4x cubed here. That's the only one I got. I'll look for x squared. I've got plus 6 here and plus 12 here. 6 plus 12 is 18. And then I'm looking for my single x's here, negative 10x and plus 18x. Negative 10 plus 18 is plus 8. And finally, I have a negative 30. Hopefully you got the same thing. Now, if the numbers get ugly, and you're like, I don't want, like if this was like 15x plus 45 instead of 4x plus 10, you may not want to do all that multiplying by 15. Something helpful to notice is that 4 and 10 are both multiples of 2. I could have taken the 4x plus 10 and written it as 2 times 2x plus 5, effectively dividing a 2 out of each of them and putting it out front. Why would you want to do that? If I had the 2 here, I don't have to worry about it until I'm at the very end. I could work with smaller numbers. In this case, I could factor out the 15 and have x plus 3. While doing all that multiplying through with the x plus 3 is a lot easier than working with the 15 and the 45. And all I got to do at the end is multiply back through by 15. And I will show that when we do more of those. When we're doing polynomials. All right, let's take a break. The next class starts at 3:10. Rest of the people coming in, let me hit stop on the video. Any questions over there, Chris?
No,